right, let's put our fancy Venn diagramming skills to use evaluating arguments. And remember, when we evaluate arguments, we always begin by examining the argument's form, not its content. What we want to know is, are these ideas put together in such a way that they're reliable? And we do that by asking this question. Is it absolutely impossible for that conclusion to be false when I assume the premises are true? Or can I think of a way the conclusion could be false even when I assume the premises are true? Okay, so if it's impossible, it's a valid argument. But if it's possible for that conclusion to be false even when the premises are assumed to be true, that's a broken clock, invalid argument. And the important point to remember here is we don't concern ourselves with whether or not the premises are actually true statements. When we're evaluating for validity, we just assume the premises are true, even if we know they're absolutely false. Okay? Now, the first kind of argument that we're going to look at are called immediate inferences, standard form categorically immediate inferences. And all that means is it's an argument that has exactly one premise. We can jump immediately to the conclusion from that premise, an immediate inference says. All right, so let's take a look at that and look at how we use Venn diagrams to determine whether or not these immediate inferences are valid or invalid. So here's your argument. Some mosquitoes are lovable bugs, therefore some lovable bugs are mosquitoes. Okay? What we want to know is, does that conclusion statement have to be true when we assume the premise is true? And the way that we're going to answer that question is by creating a Venn diagram. And we're going to mark the premise of the argument only. We never, ever, ever, ever mark the conclusion. Okay? So we mark the premise and we put our pen down and our work is done. Because what we are looking to create is an illustration of the premise statement when it's true. And if after illustrating that premise statement, we see in that same Venn diagram the conclusion statement, then we know that the conclusion follows with logical necessity from that premise statement being there because it's reflected in this Venn diagram for the premise statement. So if the conclusion appears in the Venn diagram that we marked for the premise, that's a valid argument. But if after marking the premise statement we don't see the conclusion, that tells us we don't know if the conclusion is true or false in this argument, and the argument is invalid. All right, so let's take a look at how we do that. So remember, we shade to show all or no statements, and we mark an X to show some statements. Our premise statement is a sum statement. So we're going to mark an X somewhere. Where do we mark the X to show that some mosquitoes are lovable bugs? Did you say area 2? Rockstar. Yeah. Okay, now we put our pens down. We've marked our Venn diagram to show the premise statement. And the question for us is, does this Venn diagram for the premise statement also illustrate the conclusion? And the answer is yeah, it does. The Venn diagram shows the premise statement, some mosquitoes are lovable bugs, but that X also illustrates the conclusion statement, some lovable bugs are mosquitoes. Okay, so think about what that's showing you. That's showing you that when you assume the premise statement to be true and create the Venn diagram to illustrate it, the conclusion statement can't be false. It's right there in that one Venn diagram. And that proves the argument is valid. It's impossible for the conclusion to be false when we assume the premise is true. Now let's take a look at this argument. Some logic students are flibbertigibbets. What? Therefore, some logic students are not flibbertigibbets. Why did I choose that word? That's goofy. Okay, so again, we're going to create a Venn diagram. Premise only, never the conclusion. Okay, so if we want to mark the premise statement, some logic students are flibbertigibbets, we got to put an X somewhere. Same place we put it in the last Venn diagram, right? Area 2. And now the question for you is this. Do you see the conclusion statement? The conclusion statement says that some logic students are not flibbertigibbets. Do you see that statement reflected here? I don't. If I did, I would see something like that, right? We'd see an X over here in area 1. That shows the conclusion statement, but I don't see that here, okay? Now you may be thinking to yourself like, well, yeah, but you didn't turn out the lights in area 1, so if their lights are on, there's something there. No. There may be something in area 1. There may be something in area 3. I just don't know. The only thing I know from the premise is that some logic students are flibbertigibbets. So I get to mark this X here to represent that premise statement. But that premise statement does not necessarily give me any indication of what may or may not be in area 1. Okay? So that means maybe there's something there, and this conclusion statement would be true. But maybe I'll learn something later on that says, hey, you know what? Shade out area 1. Maybe later on I learn something like all logic students are flibbertigibbets, not just some of them, all of them. In which case I'd be shading out this area 1. Okay, but I don't know whether there's anything or not. So for now, keep the lights on, but the conclusion of this argument does not follow from the premise, and therefore the argument is invalid.